All right, I'm back. Sounds like I have audio. All right, welcome to Office Hour 8, otherwise known as the final countdown. We're down to one chapter, which is chapter 11, which is acids and bases. So there's a couple of different definitions of acid base. Of course, this is not a literature class, so what we need to be able to do is use the language properly. So acid is something that produces H plus in solution or hydroxide in solution. That's Arrhenius's idea. That's over 100 years old. And then Bronsted and Lowry both came up with this other idea. It's a more general idea, but basically a proton donor, that's about the same. But here it's proton acceptor. And so if you think about it, if hydroxide accepts a proton, you get H plus, OH minus, you get H2O from that. So that actually describes how acids and bases neutralize each other if the bases have hydroxide of some sort. However, there's some other things that this definition covers that this one does not. So for example, if you have a weak base, so strong bases are any hydroxides that are soluble, which is mostly your group 1A, sodium hydroxide, potassium hydroxide, and so on. If you have a compound based on ammonia, or any compound with a nitrogen covalently bonded compound that has two unpaired electrons, this lone pair of electrons actually will accept a proton to become a quaternary nitrogen. You can see 4 covalent bonds. There's 3 in a lone pair, 4 covalent bonds, and it'll have a net positive charge. And so R1, R2, and R3 could be hydrogens or any other organic stuff. So this class of compounds are called amines. The other thing that you need to know is your strong acids, which is in table 11.3. Now in table 11.3, the one that's not in there is chloric acid, HClO3. And the other thing you need to know is how to name these acids. If it's a binary acid with 2 elements, H and then another element, it's called hydro something ic acid. If it's an oxy acid, then if it's related to an 8 ion like nitrate, it's related to nitric acid, sulfate, sulfuric acid, phosphate, phosphoric acid, and so on. If it's an ite, it's an us acid, so nitrite, nitrous acid, phosphite, phosphorus acid, sulfite, sulfurous acid. So that kind of covers the first couple of sections of chapter 11. Then talks about the chemical reactions of a compound with water, which has an equilibrium constant associated with it if it's a weak acid. If it's a strong acid, it's one way. It doesn't really have a good equilibrium constant because the denominator is very close to 0, which means K is very, very large. But for weak acids, mostly K is less than 1, so that you actually have more of the neutral molecule or the original substance rather than having it producing ions, H plus or H3O plus. The other thing you have to be sophisticated about is about H plus and H3O plus are really synonymous, and they differ by H2O. So if you have proton H plus, well, it has no electrons, so it's just the nucleus of a hydrogen atom. That's going to attach to a hydrogen, to oxygen atom in a water to produce H3O plus. Okay, so H plus aqueous and H3O plus aqueous are really synonymous. They only differ by the H2O in the formula or not. However, once you can be able to write the chemical equation, you should be able to write the equilibrium constant expression, and then actually be able to solve problems with the equilibrium constant, given some of the concentrations. And then finally, the last section is buffers. Now, buffers are kind of special in that they have both a weak acid and a weak base conjugate pair that are produced, not only produced, but actually added. So for example, if you have nitrite, a weak conjugate base of nitrous acid, also a weak acid, the mixture of these two together produces something called a buffer. And the pH of this buffer is very close to the pKa of the oops, sorry, that's not a 3, that's a 2. Nitric acid, strong acid. That's weak acid is nitrous acid. And so pH is the logarithmic scale of the H plus concentration. So most H plus concentrations are less than 1, which means they have a negative exponent. So if you take the log of that, you're going to get a negative number. Well, people don't like negative numbers, so they just change the sign. And so the pH is usually a number between 0 and 14, although it can be past that range. And because you changed the sign, it actually changed the order of the numbers. So the pH scale seemed backwards to most people at first. The higher the number, the more basic the solution. The smaller the number, the more acidic the solution is. So the text actually has lots and lots of examples. And then finally, there's a section of reactions of acid, neutralization of an acid with different types of bases. There's carbonates that are bases. So carbonates, Cl3 2-, it requires 2 H pluses to make carbonic acid. The other two require 1-to-1 ratio. Hydroxide will react with 1 H plus to produce water. An amine, like this, will react with 1 H plus to produce the quaternary ammonium cation, which of course is the cation part of a salt. And so if you use hydrochloric acid, you'd have chloride, and a chloride will go with this cation. So if you look at your Benadryl package, it'll say so-and-so amine dot HCl, which means it's been reacted with hydrochloric acid. So the H plus goes onto the nitrogen, and the chloride becomes the anion, and you have a positive ion that's very large, and a chloride, negative charge. It's a salt that will be soluble in water. So that's why they make these hydrogen chlorides for amine-type medicines. So I believe that's all I have to say about acid and base. If you have any clarifications or questions about that, I'd be happy to take them. Just want to remind you that the workshop is not due like Tuesday this week, but it's all the way till Friday night. I know this is kind of a funny time, but really there's no good time on the weekend, is there? Anyhow, so workshops are due Friday night, and you can start signing up for the exam with ProctorU, and the exam window is Friday morning at 8 till Wednesday night at 10 o'clock, basically, because it's a 2-hour exam. You have to finish by midnight. All right. Do we have any questions, Duncan? Is there a study guide for the final? I don't have one. The SI instructor is working on some mock exams, and so he'll have some exams for the second half of the material. The first half will be so the exam material will be mostly chapter 6.3 onward, omitting, so not much, through chapter 11. And so there will be a little bit from the prior material, maybe a third at the most, maybe a quarter from the first, 5 chapters 2, 3, 4, and the little first bit of chapter 6. But most of the exam will cover the rest of chapter 6 all the way through chapter 11. One thing I plan to do is put up an old exam as well. But as far as a study guide, just know how to, let's see, I might have old exam. Send me an email about study guides. And it's the finally cumulative. So partially cumulative, yes. Like I said, the exam will have about a quarter from the first semester, from the midterm stuff, but most will be the second semester. So for example, I want to point out for the acid base, most of that material, if we have to deal with the equilibrium constant, that is of course the topic of chapter 10. So if you're going to be tested on the equilibrium constant, it will probably be in the context of an acid-base reaction. Yeah, so the lowest 100-point grade will be dropped. So whatever that is, that's going to be the homework, cumulative percentage. That won't count the extra credit in the homework. That just gets added to your point total period. So that's separate from the regular chapter homework assignments. And so let's say you got 40 points on the dynamic schedule modules. That's going to be separate from your homework. It'll just be added to your homework grade. Not homework grade, but your total points. So if you got a 90% on homework, you know, the chapter homework, the midterm you got a 90%, and the final you get a 0%, and then the quizzes you get 90%. Well, your average is 90%. But it's all based on point totals, and so if there's a few extra points in one or the other, it just counts as that many points instead of the percentage. I may also, if you look under files, under you might see what the exams were for the regular, you know, class where people could actually attend a lecture. They have some exams as well. Exam 1, 2, 3, and 4. The final will cover more of 3 and 4, a little bit of 1 and 2, just like your midterm covered most of 1 and 2. So there'll be something on Canvas, and this will be an extra credit, actually point opportunity, about 15 points. And basically it's just an old exam. And then if you look under files and exams, you can see some of the other classes, old exams, I believe. Yeah, the final will be able to be dropped as one of your 4 100-point grades. One of the things I found interesting about the acid-base chapter is aspirin is a acid-base system. So aspirin, when you take it, is usually deprotonated acid, so basically the proton is off. And when it hits your stomach, which has a lot of H+ in there, it becomes protonated and neutral. And that neutral compound is actually able to go through the lining of the stomach and get inside your bloodstream, and it causes bleeding. So that's one reason why a lot of these compounds, non-steroidal, anti-inflammatory, I can't remember what D stands for, but NSAIDs cause bleeding. And so one way to actually treat that is if you have to take aspirin, like if you have let's say you had a heart attack already, and the doctor says, well, you need to keep taking a baby aspirin every day. Even though it causes bleeding, you can actually prescribe the medicines that reduce the amount of stomach acid, like Nexium, to kind of lower the risk of bleeding, because that's a problem in itself. There's a lot about stomach acid in the book. So if you have a lot of stomach acid, that's okay, but if it keeps going back up through your esophagus, it can cause a lot of damage. It's actually an elevated risk for esophageal cancer, which is, of course, not good. So even though it seems like it's just heartburn, it's a risk for cancer as well. Two things: there's the dynamic module, that's extra credit. The homework follow-up, that counts as your homework grade. So so the terminology is slightly different. So dynamic study module, extra credit, and the follow-up for the homework chapter, that counts as part of your homework grade. So what I'll do is at the end of the semester, download a spreadsheet of all those things, and I'll have to separate them out. I'll add up all the dynamic study module points just as straight points, 5 points each, and add that to your final total. But the homework grade, if it adds up to 430, I'm going to divide by 430 and get a percentage, and that'll be your homework grade. And the other thing I'll have to do is actually manually check and make sure that if you scored well enough on the homework to test out of the follow-up, that the system did actually do that right. Because there's a few examples where that may have been right. And if you're kind of close, I'll kind of give you maybe most of the credit. If you want to take the final exam early, and the due date for homework and all that stuff is, like Sunday night or whatever. Yeah, those are all separate due dates. I just tried to arrange it so that their due dates were due before the last time you can take the final. Because most people will wait as long as they can to take the final. But if you take the final first and the other things are still open, by all means, do them. The dynamic study modules can be done at any time. You'll get credit only by the deadline. Well, if it's really close, so I'll probably wind up scaling a little bit. So if that's generally the question, yes. But I won't know exactly until I get the final grades. What will you be allowed to have? So, for example, I will provide things like table 9.7, which is the rules for the soluble compounds. Periodic table you can print out. 2 sheets of scratch you can print out. Not print out, but have. So what you're allowed to have is calculator. Make sure you have a calculator. Don't use a phone or the computer calculator. Make sure you have one of these things. A periodic table printed out and 2 sheets of scratch paper. That's what you have. Any other numbers most likely will be given in the exam. So like, for example, if you need to know the electronegativity of fluorine and nitrogen, because you want to know if the NF bond is polar, covalent, or whatever, you'll be given those numbers. So numerical data you're always given. For example, the gas law constant. And various equations probably you'd be given as well. So the question about the homework. So, Pearson assigns X amount of points for every question, and that number is not going to be 100 points total. It's going to be whatever their number of points is, and I'm going to convert it to a percentage, and that percentage is out of 100. So if you did all the homework, you should get 100 out of 100. Pearson does not assign a grade. I assign a grade. Homework is worth 100 points, and it's based on the percentage of homework assignments you do, right? So if Pearson says total homework assignment points added to 430, you get 430. Out of 430, that's 100 points, percentage-wise, okay? Now, the dynamic study modules are 5 points extra, period. So if you did 8 of those, that's 40 points added to your total at the end of the semester. Okay, so the dynamic study modules are quite useful to actually master. So remember, the point of homework is to practice doing problems, to enable you to pass the exam questions. That's what homework's about.